is the vertical asymptote. So we see that this asymptote, like the graph, gets to the asymptotes but never touch them. So it's really close to them but never touch them. And then we got like this intercept that we get here in order to find one of the sides. And with the numbers, or we find like that the graph is on this side and this side, we plotted the other side. So this is the graph that we obtained from the previous function. So from this function, getting all the elements, we are obtaining this graph. So was this clear to everyone? How we graph a polynomial function is important to define. So the most important are to define the asymptote, so horizontal, vertical, or oblique. In this case, we didn't have oblique because I explained they have like different values. And then we need to find the zeros that are important too. And then we take some of the values, positive or negative, and we define here some of the values. We plot them on the graph and we get these values. We know that this, for the asymptotes, the graph needs to go slower and to reach the asymptote but never touch it. Oops, sorry. Is it clear this to everyone? So I can continue to the next chapter to say. Okay, I guess no questions. So now we have now the definition and properties of logarithms. What is a logarithm? Is nothing but expression of exponents that can be used and solved using concept of exponents only. So it's the diverse operation of exponents. A logarithm is defined. So this is the definition of the of logarithm. So we have that b on x equals to a. This is the exponent. And how we define logarithm, we have logarithm, b goes down here, and then x is the solution, and a is here. So this is how goes, like how we define logarithms. So we have log that stands for logarithm always. It's written like logarithm of a. So the logarithm of a, that's the value, with the base, b is base of b, and equals to x. So because the sign is reversible, so it means that b on x equals to a is lead to log of b a equals to x, or it says the exponential to logarithmic form, or the other way around, we have the logarithmic form to exponential form. So if I have this, I can get this, or vice versa. If I have the exponential form, I can get the logarithmic form. So they're opposites. Here are some examples. So we have exponential form as well as the logarithmic form. So for example, for this one, we have 2 on degree 5 equals to 32. Then if I look for logarithm, we have logarithm of 32 with a base of 2 is 5. Or how we solve this easily is we take logarithm of 2. Instead of 32, because I have here the base is 2, I try to write this number like 32. As numbers, I see how many 2's can get inside 32. So I can divide 32 by 2 and see how many are inside. So now we calculate how many 2 we have. We have 1, 2, 3, 4, 5. So we know that in order to get 32, I need to multiply 5, 2. So I can write this one 2 on 5. And then the answer, because this logarithm is the same, it goes to 1. So the answer is this 5 that I get. So the degree from above. This is how it's easy to find these logarithms. So for example, here I have another example, 6 squared equals to 36, or logarithm 36 with base 6 equals to 2. If you have 3 on degree minus 2, that equals to 1 over 9, or logarithm of 3, 1 over 9 equals to minus 2. This is a special logarithm, e on degree 2, and 10 on logarithm and 10 on third. These are the last two are the special algorithms because they have different names. So the logarithm of e is called the natural logarithm, and the logarithm of d is called the common logarithm. So when we have logarithm with base 10, we don't write the base. And when we have logarithm with base e, we just write ln. So if you have exercise that it says ln, that you're going to know that the base is e. Or if it says just logarithm, you will know that the base is 10. Here's the example. So if you have e on x equals to 2, you have logarithm of e of 2 equals to x, or ln of x equals to 2. It's going to be the same one. Now we have the properties of logarithms. So there are 4 important logarithm properties. We have the product property, or logarithm m times n with base a. We get logarithm with the same base of m plus. So when we have multiplication of m per n, we just sum them. If we have division here, we minus them. If we have power property, so like this, we put this in front of the logarithm, like here. And when we have logarithm b of a, we have logarithm of a. I can write it down like logarithm of a versus logarithm of b again. This is like 10 here. It's not written. So I can write it down with the base logarithm that we talked before. Okay, so apart of this, there are other properties of logarithms that we're going to talk about. So if a on 0 equals to 1, so each number on degree 0 is 1. So if we have logarithm of, doesn't matter which base, of 1 will always equal to 0. A on 1 equals to a. So this property is the one that I used before in the other exercises. So when I have logarithm of a, this equals to 1. This is one of the most used ones. So if we have like this, a on logarithm of a, this again will be 1. So we'll stay 1 of x will be just x. And the last one, if we have like this, we saw m goes here front. And when there is degree in the base, we put it down. So over it. So we have m over n logarithm b of a. Okay, so here I have all the rules that we use. So we have the logarithm a of b times c. This is the one that I write for the product. This one is the one for the power that goes up front. Then we have, if we have 1 over b, the minus, it goes minus up front, and then is logarithm of b. Of 1 will be 0, as explained. Of a will be 1. If it's on degree r, it will be just r, the degree. Then if we have fraction in the base, then it goes again minus down in front, like here. If we have multiplication of two logarithms with them, so logarithm a of b times logarithm b of c, I can write it like logarithm a of c. I can combine them because this base and this one are the same. And then if we have logarithm a of b, we have 1 over logarithm a of b. This is like the reverse property if I want to change the base and the number. So then this one I explained, like if there is the same number here and here, then it goes like the result will be n over m. Okay, so these are all the same rules as well. I have the equality rule that I didn't mention. So when we have two logarithms with the same base, then the numbers equal themselves. So we can write it down, like we can solve some exercises. I guess these rules are easy to remember. Just like when you have a product, you use plus sign. When you have division, you use minus sign. If its power goes up front, and so on. Is there any questions till now? Guess not.
Everything is clear, guys.
I'll just explain this one more for natural logarithms, and then we have like 2 pages exercises, so we can practice these logarithms. So when we have natural logarithms properties, this is ln. They are the same rules applying for these two. So we have ln of 1 equals to 0, ln of e equals to 1. When it's multiplication, we have summing of the first one plus the second one. When it's division, we have minus sign. And when there we have power, so they're the same rules applying as well for the natural logarithm. And we need to know the logarithm was 1 equals to 0. It doesn't matter what is the base of it. Okay, now we have some exercises. So now we have the short form. We want to get to solve the expressions, expand them, because like that they will be easy to solve, and like these are hard usually to solve. So I can start with the first one, and if someone has questions, they can let me know. So I can write down like first the base. I can write down like logarithm of a, and up we'll have x squared y third. So I just write the logarithm up and down because it's for both of them. Then we apply the rules. So for this one, it was the multiplication property rule. So we know that for the multiplication, we used sum of the numbers. So we were adding them. So I can separate them. The first one to be logarithm a of x squared, plus the second one will be logarithm, again with the same base, y squared, y1/3, sorry. Then down, again, we have its multiplication of m to m. So I can separate them as well. So logarithm a of m plus logarithm a of n. And now we use it up front. So we take up front 2 and 3. And the end we'll get, so 2 logarithm of ax plus 3 logarithm of ay. Now, instead of the fraction, when we have the division, for this division here, we were using minus sign. So I will have minus instead of the division, and in brackets, because this minus replies for the both terms of the denominator. So the terms minus the terms of the denominator that I get there. So logarithm a of m plus logarithm a of n. Is this clear?
Yes.
I guess it's clear to everyone. So I want you, like all of you that are present in the class, to try to solve all of this by yourself, because I'm doing it anyway slowly. Like try to do it by yourself. I'll give you the answers, but just have someone like try to do the second one already or no? Okay, I guess no. So I will explain the second one too. So we have here that the logarithm of 3, we have square root, and the square root we can write it down as fraction 1/2. Then we can use the power property. So when 1/2, we take it up front. And we have what it left inside. Logarithm 3 of 5, a on 7. Now I have 5 times a. So I can separate this is like the multiplication rule. So instead of having this multiplied, we need to do sum of them. So I have 1/2. For the first one, I have logarithm 3 of 5. And for the second one, this is the multiplication, I have the plus sign. So now will be logarithm 3 of a on 7. So a has power itself, so as well, so I have 7 on power. So I can take this power up front of the logarithm, but that is just for a. For 5, it doesn't apply, that's why I didn't put it. So we have 7 up front, and that what stayed inside is logarithm with base 3 of a. Okay, is this the second one clear?
Guys, it's clear. You have to participate in the class, guys.
Yeah, I will appreciate if you participate more. I want to know like if you understand the stuff.
Yeah, the class is for you because we want to learn more, because when I see the sound blocked because maybe you don't understand algebra or precalculus or some other topics, you have to be sure that this class is clear for you. Okay, just participate clear because this is very important. We want to be sure that everything is clear for you, okay?
So when you have like everything, like I'll appreciate that, as I told you, so you can try to solve it yourself, giving a time. As you can see, I'm just using this 4 like important properties that we had. That was the power rule that I take it up front, the multiplication rule that I'm adding the numbers, and the division rule that I am subtracting the numbers. So they're just like the basic rules that we are using. So for example, this one, the third one, I can do like a squared b. So I can separate again the logarithm of 4 for the up and down part. We have 5 up front, and then I can write down like logarithm of 4 of a squared b up, and down I have logarithm 4 of n. And on third. So now I have like this 5 up front. I can put like this 5 because it's for both of them valid. So first I want to separate this logarithm 4 of a squared times b. This is like we were adding, if you remember, as I explained before. So that means that these two from the first one will go up front of a squared. So the square will go up front. And when I multiply it by 5, so 2 times 5, I will get 10 out of it. Or I can write down like this to be more clear for you. So I have 2 times 5 times 2 from the first one. And then I have logarithm with the base 4 of a. Then for the second one, I don't have any power on b. So I just write down 5 logarithm 4 of b. Down what we have now the power 3 on n. So I take that up front, but I have this 5 as well. So it will be 5 times 3 logarithm 4 n on n, because I put that 3 up front. And in the end, what we will get is 10. I copy this logarithm 4 of a plus 5 logarithm 4 of b. And instead of the division, as explained before, we put subtraction. So minus 5 times 3 is 15. We have logarithm with base 4 of n. I hope these are clear to everyone. So if you have time, like in order me not to continue to solve them all, I prefer you to solve it. So take them down, write down on the paper, or just take screenshot as you wish and solve it by yourself. It will be better for you. I will leave it and I can continue with the next ones. Okay. So this is the opposite. I will just like do 2 of them, just you to see the different types. So now we have like the long term, we need to do it shorter. The important thing is the base is equal for all of them. So 5, 5, 5. So the base is equal for all of them. So what can we do? We can take out the base up front. So let's first solve this one. First, we have this one 4, that was the power. So I need to return the power back. So it will be x on 4. Here we have power 5. We need to return it back, will be y on 5. Okay, and then we have the plus sign. The plus sign was multiplication. So from the first term, I will get logarithm 5 x on 4 y on 5. So I move the powers. And then minus was division. Down I have logarithm 5 of z. So what we were doing now, we take logarithm of 5 of the base 5 up front. And inside we will get x on 4, y on 5 over z. Okay? I don't know if you find this easier or harder, but it's just the reverse operation. This one, the second one, I will leave it because it's the similar as the first one. So just like you need to take the powers, put it back, and then solve it. So this one is a little bit, is easy as well, but it's like 1 over 3. We have this 1 over 3. Let's first do the brackets. So we have this 4 as power. I need to return it back. And this plus sign, it was multiplication. So we have 1 over 3 logarithm base 2 s on power 4 and just t. T doesn't have any power. There is nothing up front. And now what is 1 over 3? So 1 over 3, as we solved with the previous one, when we have degree here, 1 over 2, is just square, is just the root of third degree. So we have logarithm 2 third degree s on 4t. Is it clear how to solve it? The next two are the same ones. So we have the power that goes up front. In some of the cases, like this one and 9, we can take number up front. Why? Because 4, 8, and 16 have a common factor. So you can take 8 up front and then have the other rest of the powers on it. I will leave the 3 of these you to solve by yourself. Just please copy it or write it down. Do you have any questions till now? Like, are these exercises that I was solving clear for you? Like, if you don't want to talk, at least chat, like say if it's clear or no.
Do you understand everything, guys? We want to be sure. Okay, Camille say yes, it's clear.
Yeah, clear.
You can continue.
Okay. Okay. So now we have another example. So how the logarithmics are connected, how we solve them. If we have logarithm 7 of 49, this is the example. We have logarithm 7, we write 49 as 7 of square 2. We can take the power up front, will be 2 times logarithm 7 of 7, and that is 1. Here we have other examples of that one. Like example 125, we can write it like 5 on degree 3. 1 over 16, I can write it down like 2. Okay, let's solve this one. So I can write down like logarithm to 1 over. So in order to get 16, how many 2 we have? So we have 2 times 2, 4, times 2, 8, times 2, 16. So we need 4, 2. Or you can write it down like logarithm with base 2 of 2 of the power of minus 4. So remember this rule for exponentials. When it's 1 over the exponent, when it goes up, it's just minus sign in the exponent. So now we can take like this power thing, we take it up front, so the result will be minus 4 times 1, because logarithm of 2 with base 2 of 2 will be 1, or just the result will be minus 4. The same way we can solve the other ones. So for this one and this one, this is the easiest, it's the same as the example. The second one, I just solve it. The third one is the same as the second one. You just need more 2. And the fourth one, you can put this power back and then multiply 3 4 times. So will be 3 on power 4. 3 times 3 times 3 times 3. And that is 81. Or 81, you can write it down as 9 of degree 2. So we can write this down as logarithm of 9 on degree 2. We can take these 2 up front now. And will be 2 times 1, or the result will be just 2. I think it's clear, this one. So this is how you solve actually the logarithms when you don't have A, B, C, V, when you don't have letters. This is how it works. Okay. So now we have graphing of these functions. So exponential graph is a graph of exponential function. It has a horizontal asymptote, but not vertical asymptote. It can be done by plotting the horizontal asymptote, intercept, and few points, as well as all the graphs that we already do. And the horizontal asymptote in this way, it's important role for graphing exponential functions. For example, horizontal asymptote for f of x, 2 on x is 0, but when we have g of x, for example, 2x minus 3, when we have this component here, like the number, then the asymptote, when there is no number added, that the asymptote is 0, y equals to 0, the line, and when we have a number, then the asymptote will be y equals to minus 3. This is really important to how to find the horizontal asymptote. It's really easy, but you just need to know this rule, to say. For example, we have one function. This is the 2 on x. We get some numbers, minus 3, minus 2, minus 1, 0, 1, 2, 3. And we plot it. As we saw here, as we saw before, the horizontal asymptote will be the x-axis. Why? Because there is nothing added to the graph. It's just 2 on x. So we see how it reacts. So let's see more details about it. So this is how, like, what is important, how you can know how the exponential function works. So this one is y equals to 2 on x. If we have 5x, so if this one is bigger, then goes in this direction. If it's smaller till 1, will be like here, this way. If it's between 0 and 1, will be the opposite direction, as you can see here. And always the degree, this we just talk about the degree x. So when the degree is just x, without added numbers. So now if we have minus x, so we see how is 2x the function, this one here. Minus x, when it's the exponent, it's the opposite direction. So it will be like here on the graph. In this way, just will be the same as this one. And then when we have minus up front of the function, that will have it down the function. So minus 2 on x. It will be like reverse, like a mirror, to say. So this is when we are adding elements. So for example, if we have x plus 3, but this is in the degree up, so it's in the exponent, then the function, as you can see, this one was 2 over x, that moves, the function moves, as you can see, for 3, left or right. So when there is the number in the unit, so up here plus 3, it moves for that, like here is explained. So when we have, for example, if here is 3, that translates 3 units into the left. So 3 units, so for example, from here, 1, 2, 3 till the left, and we get this function. If we have minus sign here, it will be opposite. It will translate 3 units, but to the right. Okay, this is like the easiest how to plot functions, because you will have just the basic. Normally, you'll have just this, the basic 2 on x. And then in order to plot it, you just need to play with these numbers to know if you need to move left or right, if you need to move up and down, like in this one, when there is a number afterwards, it's +4. In this case, we have the horizontal asymptote, we have an +4. So we will have the horizontal asymptote here. So we'll come the line here, always move the line from 2x. Here's the function 2x is moved for 4 units upwards. So it goes up. If we have minus here, it will go 4 units down. So depends, and it's really important if this number is in the degree up here, because when this in the degree goes left or right, when it's out of the degree goes up and down. Is this clear for exponential functions? This is how you plot them. So you plot the base and then you move it. So when we have, so these are the use properties of, now we have for the logarithmic function. So as we know, the logarithmic is inverse of the exponential functions. So we have properties of logarithmic function. If a is 0 and a is bigger than 0 and is different from 1, the logarithmic graph increases. Why is different from 1? Because if it's 1, we get 0. And it needs to be the logarithmic function bigger than 1. Logarithmic graph increases when a is bigger than 1, decreases when it's between 0 and 1. So increases goes up and decreases goes down. The domain is obtained by setting the argument of the function greater than 0. Any set of all the real numbers, the range is the set of all the real numbers. Okay, so this is the same if the curve is increasing or not, depends on the base of the function. So if a is bigger than 1, then, or if the base is between 0 and 1. So now we will have the graph of this logarithmic function. The function is f of x equals to 2 logarithm 3 x plus 1. Here the base is 3 is bigger than 1, so the curve should be increasing. For the domain, this one x plus 1 should be bigger than 0. So the domain will be from -1 till infinity. We have the vertical asymptote when the x equals to -1. So in this one. Then we have for x equals to 0. So this we find the intercept for x equals to 0. We have that y equals to 0. We have logarithm 3 of 1 and everything. When there is like in the here 1 is 0, and when we have for at x equals to 2, we try to solve it and we get is 2. So we try to find like 2 real numbers and we do like randomly table, so we get mode points to graph it, and in the end this is graph what we obtained. So what we saw first that the curve is increasing. So here it starts from down, it's increasing. It has vertical asymptote. So it says that the vertical asymptote is at -1. So, So here we have -1 vertical asymptote. As we see, the logarithmic is the opposite of exponent. The exponent was going like the other direction. This is like the other one. We find these 2 points that are involved. So 0, 0, and 2, 2. So, and this is the graph of the logarithmic function that I just mentioned. Here as well, the examples. So what we have, they apply rules as well as for the logarithmic function. So can be shifted k units vertically and h units horizontally. So if we have like this given, so the base, what you're going to write is this one. So you're going to write a graph of this one. And then we have if h is bigger than 0, so if this number is +3, +4, +7, doesn't matter the number, then the graph should be shifted in the left. So for example, we get log b of x, and then if this one is positive, we shift it up in the left. If it's negative, for the same amount of units, if here it says +3, we shift it for 3 on the left. If it says -3, we shift for 3 on the right. And k, that is outside of the logarithm, so it's given, but it's outside of the logarithm, it shifts upwards or downwards. For if k is bigger than 0, go upwards. If k is smaller than 0, go downwards. So the same graph, first you shift it left and right, and then what did you get? You shift it up and down. It applies the same rule as for the exponential function. So that's it from the today lessons. Was it everything clear? Like as well with these graphics that I explained?
Guys, is clear? Everything is clear?
Yes, teacher.
Okay.
Good, I'm glad. Okay, so it was pleasure to give you this lecture. I hope you enjoyed and you understand and you took some of the exercises that I gave you to solve it at home. So I hope
Okay, excellent.
everything is
Excellent.
clear. Finish.
Thank you so much, Emilia.
Thank you. Thank you too for attending the class.
Hey guys, you know, as I told you